have been given permission for record, okay? Okay, Inan responded. He is telling his peers probably to join. Okay, can you see this text?
Yes, sir.
Okay. Yes, then when you will be logging into your site, because this is probably administrative site, you are seeing many things, but probably you will not see that many things in your case, okay? What you will see, you can concentrate here, okay? Say mid question, mid exam Q1, mid exam Q2, mid exam Q3, mid exam Q4, something like this, okay? Actually, according to our OB policy, actually there exists no what we call opportunity there to give some choices actually. For this reason, what I will do, I will be giving some or questions. For example, in question one, you may have in two questions I will give or, okay? That either this or this you can answer. Then you will have you three questions there. Then when you log in, you will find this thing, okay? That your thing will be appearing in this way, okay? I am showing you one. When you will click it, this thing will not appear to you, just I am giving you the preview so that the thing will be something like this. For example, say when you will be clicking to any test, then a question of this type, according to your subject content will appear to you, okay? It may contain some figures also. So when you will have this thing with you, your marks will also be declared in it like your physical exam. What you need to do, you have to answer, write your answer in your notebook in A4 size paper. Then when your answer is complete, then what you need to do, you do not put any answer here in this answer box because this answer is not correct. A fake answer is given there. Do not write anything there, okay? Without writing anything there, you can go to the next page. When you will be going to the next page, you see an upload option will be there, okay? So you can upload your file, and I know how to upload it. You can upload your file here. Okay, but for safety, what I can tell you that after uploading your file here, again you can go to your next page. In your next page, you see a Google link there. Okay, can you see that Google Form link?
Yes, sir.
Yes, sir.
Okay. In order to access this Google Form link, you have to log in using your IUT email to Google. Okay. So when you will be clicking this link, you see that a Google form will be appearing. Let me show it. Okay, when you click it, I think this form is probably closed. For this reason, you will not be seeing anything. Then what will happen? You will find a Google Sheet, okay? Like you have already used. In that case, you have to put your roll number Then in the next question, you have to upload the same file that you have uploaded in your what? LMS, okay? Now, another issue is that if your LMS will have some problem, IIT LMS, for safety, I will also be putting the same thing in Google Cloud. Do you know what is Module Cloud? In earlier cases, I have instructed you to access your Module Cloud, where you can also find the similar thing that you find in your Google, IIT module, okay? Then if someone has problem in accessing the IIT module, then he can quickly go to the link of Module Cloud and do the same thing, okay? Similar thing will be there appearing in Module Cloud, okay? This link I will supply to you. Now, is that clear?
Yes, sir.
Can you repeat the third step?
Okay, I will be repeating again.
Yes,
And what will
the
happen
third step only.
when you will click a question, then a question will appear, okay? Should I start from the beginning?
Yes, sir.
Then when you will be going to the course, okay, then you will find something there, okay, like meet question 1, 2, or 3, okay? Then you click on your question, okay? Then in your case, your question will directly appear, but now I am showing you the preview, okay, in what ways it will appear. Then you will see that this question was not is very simple, so I will be showing you question 3. You will see that after you click your corresponding mid question, okay, you will find a question appearing to you, okay, in this way. Is it clear?
Yes, sir.
Okay. Then what you need to do then? You see that some instructions will be there. Upload the PDF of your script with detail of calculation to the next question, okay, not here. So you write your answer in your notebook, scan it, then you prepare the PDF file, okay? Do not write anything in this answer box. Then you click your next, okay? When you will be clicking next, the next question here, your answer will be just you simply upload the file that you prepared previously, okay? Then when that upload is complete, then you can go to your next page. But okay, before attempting to your question, okay, you can keep logged in your Google using your IoT email. Then when you click that link, then the Google Sheet will open, okay? As the sheet is already closed, so I will not be resuming it because it will again, I have some stored data there, it might create problem. So what will happen then, in that Google form, you will have 3 or 4, 3 questions. First, you have to put your email ID. Second, you put your student ID. I will make it simple. You put your student ID. And in the next question, upload option will be there. You can upload your file. Okay, keep your file size as minimum as possible. So then you submit. You can submit your you submit your form. Then you submit your module tax. Okay, in this way you can go.
Sir, so we will have to submit twice, sir.
Yes, twice. I am taking this thing as a precautionary measure. Okay.
Okay, sir.
Okay,
If
sir,
someone will have problem in uploading the file in module, then I will use the Google one, okay?
sir,
Yes.
can you please give us a mock test, test or
Sorry?
something like that?
Sorry?
Mock test, I mean, so that we will try
Mock
to-
test, this test you can consider as a mock because preparing a mock test actually a time consuming something, okay? Do you
Just
have
maybe
any
one
problem?
question, what is your name? And
Because you have already encountered how to upload your file in your quizzes, isn't it? Then
yes,
this
but
is
we have
your,
some problems.
sorry?
I mean, we have some problems. I mean, if you can just say what is your name, something like that, even one question.
No, what is that problem actually? That I need to identify. Can you tell me what problem you faced? Because it is very simple, okay? For example, okay, let me again show it. Okay, if you are here, for example, if you have this question with you, then what is it? You have nothing to proceed with this module then, okay? What you need to do, you see your question there and try to write your answer in your what? Notebook, isn't it?
Yes.
Okay. After that, what you will do?
Click the next page.
Why you should do that? Don't you know that you have to prepare your file then? You have to scan your script
Yeah,
and
you have to scan.
and prepare your PDF. Okay, that's good. Fine. Up to this point, do you need any further instruction?
No.
No. That means in the last page, okay, you have a question, you have written the thing in your notebook. Then what you can do, you scan this thing. After having this thing converted into your PDF, then you keep your PDF file. Your PDF file should have the name that must be your ID. Okay, fine. After your file is prepared, then you go to your next page. Okay, can you see it?
Yes.
Okay, this is your first question. Okay, you are seeing the question. After you will be given, for example, some time 20 minutes or 22 minutes to write your question. But before that, you cannot submit. So after that, what you can do, you can go to the next page. When you will go to the next page, then this question will appear. Okay, in this question, what is the instruction? Upload your answer of question 3. Okay.
Yes.
Okay, fine. Then you put your file there, drag your file to this box, or you can click this button just to seek your file where your file is located. Okay, you understand my point?
Yes, sir.
You can simply drag your file in this box, in this dotted box, or you can click here. Okay, if you click here, then it will tell you that choose a file. Then when you click this choose a file, then your directory where your file is there, from where you can choose your file. Okay,
Okay, sir.
then when that is complete, you upload. That's it. Or you can directly drag your file here in this box. Then your file, it will take a bit time to upload. Then once your upload is completed, then what you can do, you can go to your next page. When you will be going to your next page, but this is optional actually. If your upload is successful in your previous case, then this is would be done. But my advice is you try to upload here also. This is for precautionary measure. Okay. Then when this question will appear, you see that question, upload the Google form, open the Google form in a new tab, put your ID and upload your PDF of question 3. Okay. Submit and return to LMS, and then you finish your submission. Okay. Then you can click here. When you will click here, your Google form will be there. Then in this Google form, you see your Google form will be looking like this. You got the point?
Yes, sir.
Then at this point, you put your ID. Then you upload your file. You click here and choose your file. Now you're done. Okay. When this is done, then again you go back. Keeping this thing open, you can also go back to your Sorry, I was disconnected because my Wi-Fi has no internet now. Okay, I connected using my mobile. Have you heard the thing that we discussed earlier?
Yes, sir.
Yes, sir.
Okay, inshallah, if possible, I may, if I can afford time, I will give a mock like something in this weekend, if possible. Okay.
Okay, sir.
Sir, it would be very beneficial for us, sir.
Okay, inshallah, I will try to do it. At least one question will be there. Then you can just follow the same process. Okay.
Okay, sir. Thank you.
Sir, in the exam, how much time will you give for uploading?
Okay. For a question, okay, you will have 30 minutes total. Then in my previous experience, we found that around 6 minutes are needed for copying or preparing the PDF and uploading. So you will have 25 minutes or 24 minutes for your writing, and then for 6 minutes for uploading. Do you think it is good? Your question will be set in such a way that you can answer it within 20 minutes. Okay,
Yes, sir.
inshallah. No problem. Your teacher is with you, no problem. Okay, he wants to know your sincerity. That's good.
Thank you, sir.
Because we know you and you know me. Okay, so for this reason, don't get panicked. Everything will be in line, inshallah. Okay. But my advice is fairness and ethical standard is very important in learning that you need to maintain. Okay. You see, in your last exams from my department, that did not happen. But in computer science, other departments, some expulsion also happens in online exams also. So be careful about that. Your misdeed must incur some what you call sanction to you that will be a very detrimental effect in future in your life. Be careful about that. Okay. I think one of the famous letter now it is available in the internet. I don't know how many of you have seen it. That letter is actually letter of Abraham Lincoln to his son's teacher. Have you seen it? Any one of you, this group who have seen this thing? Is there anybody in this class who has seen this letter? No.
No, sir.
Okay.
Sir, I have seen it.
You have seen. Can you find some listen there? Because he was the president of the United States of America, okay? The introductor of the democracy in the United States. When his son was admitted in a school, okay, he wrote a letter to the teacher how to deal with his son. That at one of the paragraph, it was written that to the extent of my memory, I am saying it, that it is better to have 10 penny with you rather than having $10 found. It is better or joyous to have a defeat than getting some what you call win by using cheating. You got my point. So if you have your time, search the internet, find the letter, original one, and try to read it. This is very good. At least you can tell someone that this is what the philosophy actually in learning that we are maintaining from the very beginning of our modern life. So let us start with, although, okay, I will give the percentage of all those who are present, okay, as my notice was given a bit later for this reason, so don't worry about your presence, okay?
Okay.
Getting your percentage is not that important than getting engaged in learning, okay? So can you please tell me where we stopped in our last class? Probably we started our numerical integration and we discussed about trapezoidal rule. We discussed about Simpson's 1/3 rule.
Yes, sir. I think
Yes, sir.
Simpson's 3/8
Okay.
rule was the last of
Then in the last class we started what?
Simpson's 3/8 rule.
create
Sir,
rule, okay?
we discussed up to that topic, sir.
Up to Simpson's rule, okay? Then today we will be discussing a bit more about numerical integration. Those techniques are actually a refinement of the technique that you have already introduced with. That means our trapezoidal rule is actually, in most of the cases, is the basis of proceeding with other rules. So we have our trapezoidal rule, very simple to be implemented. It can be implemented once or it can be implemented multiply. And you have your 3/8 rule, Simpson, and 1/3 rule. Okay, those things can be used independently. Even a combination of the technique can be used depending on the nature of your data. What I have discussed earlier, that if you have your data that in some region they are varying very rapidly, in other regions they are varying slowly, then what we can do, you will see that the independent variable or the sample points, or sometimes called abscissa, will be not equispaced, because if they are equispaced, then your algorithm will be not efficient. For this reason, you have to use your shorter segment length over the region where your data is changing rapidly, isn't it?
Yes, sir.
You can choose a wider segment in the region where your data is varying slowly. So all this algorithm can be applied prudently with judgment so that you will have less error in your computation. Now we'll be introducing two more numerical algorithms that are actually you can consider them a refinement of the algorithm that we have learned earlier. Okay, one such algorithm is called Romberg integration. It is there in article 22.2 of your book, and we have our Gauss's quadrature formula. This is there in article 2.4 of your book, and in 2.3 some other points are discussed that is also relevant for derivation of these two, because Gauss's quadrature in particular is a bit time consuming, I would say, but once you learn it, you will see that it has some beauty, okay? Let us share your book first. You see, this is your, can you see this page?
Yes, sir.
Okay, fine. You see what is written there, you can have a look. Romberg integration is one technique that is designed to attain efficient numerical integration of functions. It is quite similar to the technique discussed in chapter 21, where we discussed about the other rules, in the sense that it is based on successive application of the trapezoidal rule. However, through mathematical manipulation, superior results are obtained for less effort. That means it is somewhat efficient. This effort means it will take a lesser computational time in implementing it in your digital computer, and it will give you more accurate results of your numerical computational of your integration. So in order to derive this thing, we will be starting with this interpolation type formula. Actually, the thing is that at the beginning of my lecture of numerical integration, we have discussed, for example, a few things, that if you have your data point, actually your equation can be given. If your equation is given, you can integrate it either analytically or by using your numerical technique that you learned. Sometimes your equation may not be given, your discrete data will be given. If your discrete data is given, then you can use the discrete data directly to your algorithm, or alternatively what you can do, you can use some interpolation equation that will connect your data point. The most simplest form is your linear, okay? Linear, if you have your two segments, one segment only, in one segment you will have a beginning and an end, isn't it?
Yes, sir.
Yes, sir.
If you have your two segments, then you will have a beginning, for example, say in your abscissa, and you will have an end. Between this beginning and end, the only what you can do, the interpolating polynomial will be a straight line, isn't it? That is what the basis of your trapezoidal rule. Now, if we have our additional data points, then what we can do, we can fit these data points to an interpolating polynomial, isn't it?
Yes, sir.
And that interpolating polynomial will have an order equal to what? 2. That means a quadratic equation. If you have your n plus 1 data point, then you need a polynomial of order n to use as an interpolation polynomial connecting these data points, isn't it?
Yes, sir.
Okay, so once you have this polynomial with you, that polynomial can be say a0 plus a1x plus a2 say x square. Then what you can integrate it between point A to B with dx. That will give you your result, isn't it?
Yes, sir.
Okay. But if your data are gradually increasing, then what will happen? The order of your polynomial will be also increasing, isn't it? It will be a time consuming something. For this reason, actually, you have to apply your algorithm in such a way that you can handle your discrete data, but the derivation will be from, the concept of the derivation will be from your interpolation technique. Now, you may have some situation where your endpoints can be outside your data given to you, something like this. If you have your, say, a figure, something like this, you have your figure, you have a data point there, you have a data point there, okay? Say this is your A and B. So within this, you can interpolate, but if you are beyond this region, then what technique should be there? Extrapolation, isn't it?
Yes, sir.
Then this, you will see that some of the things will be addressed in these two integration technique. That is actually the refinement of our previous technique and having taken the advantages that we have already discussed. Now the thing is that let us start with it because this mathematics is actually not that much difficult to be understood. Actually, the thing is that when we say that we are refining something, what does it mean? In our case, the refinement is in terms of the accuracy of our integration. Another thing is that we can start with a coarser segment. Coarser segment means what? If you have your two segment there with equal to b minus a, then it is one segment, isn't it? If we subdivide it by two segments, then what will happen? Your and if they are equispaced, then what you are doing actually? Are not you halving your interval?
Yes, sir.
You are halving your interval. So previously you have a coarser, for example, step. Now you are going gradually to the finer step, okay? As you know that if we are using finer step, then intuitively we can assume that the trapezoidal rule will better fit because if we have a smaller width, then that portion can be easily approximated as a straight line, isn't it?
Yes, sir.
Yes, sir.
So this is what the logic. Now to start with, consider that we are using a coarser step first, and that step is say H1. In general, what will happen? If we have an integral, that integration has an exact value equal to I, that integration has an exact value equal to I, then we are, for example, calculating the integral with a step size equal to h by using, say, trapezoidal rule. Okay? So if we use trapezoidal rule there with a step size equal to h, then can we write I is exactly equal to IH? Can we write?
No, sir.
No. The reason is that an error should always be there. Okay, that error is also function of h. So this is what the equation you can write in terms of your approximated value of your integral and the corresponding error added with it. Then if these two are added, then you will have the exact value of your integral. Okay. So with this for general logic, we can proceed with two, for example, segments. One, say H1, another is H2. We are assuming that your H1, H2 is less than your H1. Okay. If we go, for example, in a direct way, that means we are gradually halving the step size, then you can say that your H2 can be equal to H1 divided by 2, isn't it?
Yes, sir.
Okay. Then what will happen, no matter what step size you are using, each step size will give you an integral value and an error. Similarly, if we use your final grade H, then you will have an integral value calculated numerically, and this is what is your error. But both are for the same integral, okay? Or both are equal to the same integration I, isn't it? So this can be equalized. Now we know that from our earlier text that the error of the trapezoidal rule is actually proportional to the H square. In that sense, you can see that your E1, EH1 will be proportional to H1 square, and your EH2 will be proportional to H2 square, isn't it?
Yes, sir.
In this case, what you can do then, if you write E1H divided by E2H, because you are using same EH2, same integral, then would it not be equal to H1 square divided by H2 square?
Yes, sir.
Okay, very good. So using this thing and the equation given there, we can just after a few steps of our algebra, we can easily find an equation, general equation. Our objective is what? We have to find the integral. That integral will be calculated with the help of two integrations that we have with us with two values of your age, the step size. One is coarser, another is what? Finer, isn't it?
Yes.
So if we go in this way, and whatever I have discussed earlier, then you will see that that integration can be written in this form, equation 22.4. In this, you can see, you see that H will play a factor there just to refine our what we call integration. Okay, in the sense of statistics, you can see that that I is actually a weighted sum of integrals of I1 for H1 and H2. And if we said that I have discussed earlier, the interval H2 equal to H1 by 2, then we will be arriving in a simple equation that is used in most of the cases, equation 22.2. So you can easily see that are not those factor 4 by 3 and 1 by 3 are the weights of your integral?
Yes, sir.
Generally what you can write. Okay, general can be something like this. Okay, say you have your I1, I, that I is equal to a weight W1 into IH2 plus another weight W2 into IH1, where IH2 is the evaluation of numerical integral using the step size equal to H2, and the letter is actually for H1. And you will see that this weight, this is a normalized weight. Okay, if you add 4 by 3 plus 1 by 3, is it not equal to 1?
Yes, sir.
So this is another characteristics of this weights. Okay, you have your other versions of these equations that might give more accurate result with in compared with equation 22.4. We'll be discussing that. This is applied in the example that we have started with. You can also check the result by using a known something, known function with you, okay? Can you do that, for example, in this way? Consider that you need to integrate it to the power x. Between a to b, we need to integrate it to the power x dx. Can't we find the accurate result without numerical technique? Can we? Hey, respond please. Do you need numerical technique to evaluate this?
No, sir. We
No,
can
sir.
do it.
Analytically
analytically.
possible.
Then the value is simple, e to the power b minus e to the
E to
power
the power
minus
a.
a. B plus, is it not the value?
Yes, sir.
Yes, sir.
Okay. Then if we want to, for example, plot the function, you know the nature of the function. What is the minimum value of this function? If we say that we are considering x greater than equal to 0, then minimum value will be equal
Zero.
to
Zero. Sir, e to the power 0. So 1, sir. 1.
minimum value is 1. Okay, then it will be increasing in this way, isn't it?
Yes, sir.
If we set the two value there, a and b, okay, then what we can do? Can we draw a trapezoid there? Then if by using trapezoidal rule, what will be the result of this integration? You know the thing that you have to find the width b by a, then multiply it by average height, isn't it?
Yes, sir.
Yes,
Is that
sir.
average height? Your average height would be equal to e to the power a plus
Plus
e to the power b
b
divided by
2.
2.
2. Is it not the value of your integral? I.
Yes.
Here you can consider that you b by a equal to a is a Courser what you call step.
Yes, sir.
You understand my point?
Yes, sir.
Okay. If you have this thing with you, can we calculate it by introducing another point here between a and h? Midpoint.
Yes, sir.
Yes, sir.
Okay. If we have a midpoint there, can we apply our trapezoidal rule again there?
Yes, sir.
Say your midpoint is C. Then what will be the result?
C
You
minus
have to
b.
consider these 2 points first, then consider these 2 points first. You have a thing there. Okay, you see height will be common for your both trapezoids, isn't it? Your first result will be C minus A into e to the power a plus e to the power c divided by 2. Okay, this is your first trapezoid. Your second one is b minus c into e to the power c plus e to the power
b.
b divided by 2, isn't it?
Yes, sir.
Yes, sir.
That this is also an integral you are calculating, that you can say h2. This is your h1, isn't it? If these two values are available with you, then by using these two values, what you can do, you can use this equation that our actual integral, that integral now our refined integral will be equal to 4 by 3 into IH2 minus 1 by 3 into IH1. Is it okay?
Yes, sir.
But still this integral will not be exactly equal to this one. Then what you can do, if you can say that this is your true value it, this is your numerical value you obtained I1, then you can compare this two value I2 minus I divided by IT and just give a percentage. Will not be the error of true error percentage.
Yes, sir.
Okay. Can't you formulate a problem like this by your own? You said that your A equal to say 0.2, your B equal to say 0.8. Can you proceed with this thing and verify?
Yes, sir. We can.
Without, for example, doing this example, you can set a simpler problem by your own that is tractable, okay? And that is very easy, mathematically easier to evaluate, just to verify how this algorithm actually improving your result. Then you have your three things there to compare. One, you have your exact result available to you that you can do analytically. Now you can calculate it by using a single segment trapezoidal rule that will have a Courser segment. Then you can again half your interval and calculate the integral. Then you will have three values at integral there. One is your what? One is your I exact true value. Another is I H1. Another is I H2, isn't it?
Yes, sir.
Yes, sir.
You can easily now with this H1 and H2, you have calculated an I. Then you can easily compare among for example, the result that you have. Okay, that how you things are improving. So this thing is actually illustrated for this nonlinear problem. The same integral is evaluated by using this technique. And you see that in this case, if we use a Courser technique for H is equal to a two segment there from x is equal to 0 to x equal to 8. Here you A equal to 0 and B equal to 0.8. Then this is what the first term and this is what your second term, okay? In this way, you can have your integration defined. Not only that, this algorithm can again be applied for 4 segment rather than making it 3. Can't you do that?
Yes, sir. We can.
Okay, then you can experiment it with your simple problem of e to the power x, okay? Rather than dividing your a minus b minus a into 2, you can divide it by 4, by 8, whatever way you can like, you can easily find how you things are improving, okay? Oh, 2 other versions are there. These 2 other versions are equation 22.6, 22.8. Here you see that one interesting thing is there, that a trapezoidal rule has a error in the order of h square. And when we use the integral that we derived from Berg, that integral will have an error proportional to h to the power 4. So you can easily say that if you can have a finer step, then your error will be significantly lower in compared with your trapezoidal. Then again, some other algorithm can be developed where you see that a 2h square can be used to find another refined integral whose order will be, error will be changing in the order of h to the power 6. Similarly, if we add 2h to the power 6 terms, then your order of error after refinement can be h to the power 8. Okay, the 2 equations are given there. Equation 22.6 has the order of error is h to the power 6. Something is missing there in equation 20.6 probably. Can you identify what is missing there?
22.6.
22.6. Our logic was what? The weight W1 plus W2
16
should
by
be equal
15
to
হবে
1.
most probably, sir.
Should be equal to 1. Is it 1 in 22.6?
No, sir. I think
No,
IMF
sir.
coefficient is 16 by 15.
Yes, it should be 15 by 6. Okay, please correct it. Equation 22.7 is correct. So these 2 equations are also applied in the successive examples to find the algorithm. Okay, the generalized Romberg algorithm is this. Okay, you can have a look. You will see that by using changing the value. Actually, your J index is used here to distinguish between more accurate and more less accurate result. That means by using a coarser segment and a finer segment. Okay, K is actually the integral. Okay, that you need to calculate the level of your integration. This table actually shows that if we use 2h square, this order is actually order of error. If we use to integral with error h square, then the resulting integral will have the error equal cosmos to h to the power 4. Now, another technique is there. This is very simple and very easy and sometimes lengthy to be calculated. Okay, I will be leaving this derivation for you to go through it. Please do something by your own so that you will understand something. Okay, I will be concentrating here in 22.4. Why I am leaving 22.3, it is an extension of what you have learned in our trapezoidal rule and Simpson's rule. A combined form is there and try to go through it. If you have a problem to understand it, we may discuss it in future, no problem. But here the Gaussian coordinates are actually, this is a very standard technique of integration in most of our computers. This algorithm is implemented. Although trapezoidals are there, but the Gaussian quadrature has some other technique. Actually, the thing is that it used some technique of extrapolation type, and we will see this thing, okay, that I discussed. If in the trapezoidal case, actually, if we have 2 points there, then these 2 points are, we are calculating the integral of the hashed area that is within these 2 points. But if we have our point going beyond that 2 point, then we need the extrapolated value of a polynomial. Otherwise, we cannot evaluate the integral, isn't it?
Yes, sir.
Yes, sir.
So this technique, what is called Gaussian quadrature, will help us to do that. But this technique has a very what you call lengthy mathematical reasoning. So we will not be going to the derivation. If you have your interest, then you can explore it by using some other numerical text I have cited to you. But I am just telling you the essence of our logic. The thing is that you see that our trapezoidal rule is actually a straight line interpolating polynomial, isn't it? If we have our generalized polynomial with us, then what will be the shape of our polynomial in general? Is it not equal to a0 plus a1 say x plus a2 x square plus a3 x cube, isn't it?
Yes, sir.
Sir.
So if we have this thing here, you see that A's are actually, A's are what? These are the constant that we need to determine so that the equation will optimally fit your data points. We have our two logic. One is what? Interpolating polynomial. In the interpolating polynomial, if you want to find the value of A1 through A3, how many data points you will need? You will need four data
Data
points,
points.
isn't it?
Yes, sir.
Yes, sir.
Because you have to solve four equations simultaneously to find the four unknowns A0 through A3, isn't it?
Yes, sir.
Very good. But if we have our data points that are many data points, thousands of data points we have, can we use this technique?
No, sir.
No, sir.
It is actually not efficient. Theoretically, the answer can be yes, but practically it is not efficient and not a prudent technique. In that case, what you can do, we have another alternative. What you can do for this region, you can use your fit curve, okay? That means you can use your least square fitting curve to fit your data. Then we will have a fit curve available with you, order n. Then you can integrate it numerically or you can integrate it analytically just to, because in that case, you will have a new curve continuous with you. That curve is determined by your fit coefficient, okay? But it will not be passing through all the data points, will they?
No, sir.
No. But every time they will have, at each data point, they will have a residue that we call errors. And we obtain the coefficients of the fit curve by minimizing the square of the error. So that will always be there. So with this thing, let us start with how to derive the equation. You see, this equation 22.6 is nothing but the trapezoidal rule. Is it not the trapezoidal rule?
Yes,
Yes,
sir.
sir.
Yeah, it is trapezoidal rule. Now your data points, for example, are we need to, for example, use this two thing in your Gaussian quadrature development, that if we have these two situations, that your data is constant, it is placed symmetrically with respect to your y-axis or ordinate, but eventually you have your width equal to b minus a, isn't it?
Yes, sir.
Yes, sir.
So in both the cases, your trapezoidal rule will give you 100% accurate result, isn't it?
Yes.
Yes, sir.
The reason is what? Because your data points and the trapezoid you are doing, you are using, will be coincide 100% with you in the region over which you are integrating. Your first is simply the area of the rectangle. and second can be calculated by using the area of your triangle, isn't it? Even this curve may go from other position with some intercept, and still a result will be correct. Okay, so in this case, what is happening? One technique before going to Gauss's quadrature, one technique is actually applied there. That technique is called method of undetermined coefficient. Have you heard about this technique earlier in any of your mathematical courses? You did not heard about this method of undetermined coefficient?
No, sir.
In your differential equation, for example, we frequently use this method in most of our problems. For example, if you have a differential equation, say RL circuit, okay, you can easily write that di divided by dt plus say R divided by Li is equal to E divided by L. This is what your differential equation, okay? Generally, you can say that this is something like this. dy by dx plus say a constant A into y is equal to another something you can say that this, as this is a constant, this is a constant A. Is it not the equation is something like this?
Yes,
Yes,
sir.
sir.
If this equation is something like this, how did you solve it in your first year?
Sir,
Okay.
we determine the integrating factor and then sir solve it.
Integrating factor, exactly. But integrating factor is actually will be applicable for a particular part of your integral, not to all, okay? That means you have to set your integration first, di by dx plus ay is equal to 0. That is called homogeneous part, isn't it?
Yes, sir.
Yes, sir.
That solution, you can consider that this is your complementary solution, YC. That YC can easily be evaluated with the help of the experience. The reason is that physically, what does it mean? Okay, because we have started with a real problem. Then we translated into a mathematical form general. Then we are using the conventional technique of solution of this equation. If we start from the real problem, you know the real environment for which this equation is valid. What is the real situation? You have an RL circuit, isn't it? And
Yes,
you
sir.
have excited that RL circuit by a DC voltage at time t equal to 0, and you are calculating the current I flowing through it. Is it not the situation you are
Yes, sir.
represented by this differential equation?
Yes, sir.
Yes, sir.
Yes. If it is yes, then in this equation, in the jargon of differential equation, we call it in non-homogeneous type equation. The reason is that non-homogeneous type equation will have a right-hand side that is called a forcing function. Have you heard about forcing function?
Yes, sir.
If it is yes, physically, what does it mean?
Sir,
Physically, this means that this is a source term in your
Yes,
physical system. That forcing term is coming from this concept. Force means you are giving some input to your system to have an output, to get an output. For this region, the input, you can that forcing function can synonymously called as input function. Okay.
sir, isn't it like a external excitation?
Exactly. Very good. It is excitation, exactly. Excitation or forcing function or input, whatever ways you can call it, but it is related to the input. Okay. If we have our input there, but in this case, we are setting this input equal to 0, isn't it? In the
Yes, sir.
later course of signals and system, you will see that we have also another name of this solution. Now we don't have any input now, isn't it?
Yes, sir.
Yes,
You
sir.
set your input equal to 0. If we set our input equal to 0 in this location, physically, what does it mean in your circuit?
There is no source.
There is no voltage source.
There is no voltage source means what? Is it open or short?
It is short.
It is shorted, exactly. That means now, if you want to make it homogeneous, this is not there, it is shorted. Now tell me, now this equation is valid for your short circuit or something like this, that doesn't contain any source. Okay, very good. Now tell me when this solution will be meaningful. This is not mathematics, simple common sense, okay? Tell me that solution of this equation dyc by dx plus ay, here yc corresponds to our current.
Yes, sir.
When this solution will be meaningful,
When there is a source, sir, so that we know how the current came.
but this circuit has no source.
Okay, all right.
But still we need this equation.
To determine the proof.
That is what the concept from your electrical circuit of first year. That your inductance has a property that can store energy inside it. Unless you
Sir.
know what is the situation present there, you cannot proceed with number one. So if you want to independently find YC, then your inductor must carry a current in it before application of this source. That is what the initial value. But apart from this thing, we need this solution. The reason is that we know that that inductance has a behavior that is called inertial behavior, like a mass. Time for the to be now equal to you. This is not the total solution of your system. You need a particular solution. Have you heard about particular solution?
Yes, sir.
Hey, কথা বলো তাড়াতাড়ি।
স্যার আপনার ভয়েস একটু ডিস্টর্ট হচ্ছিল স্যার।
ডিস্টার্ব হচ্ছিল, এখন তো আমি তোমাকে ক্লিয়ারলি শুনতে পাচ্ছি, তুমি আমাকে পাচ্ছ?
জি স্যার, এখন ক্লিয়ারলি শুনতে পাচ্ছি স্যার।
তো এখন ক্লিয়ারলি শুনতে পাচ্ছ, আমাকে বলো এখন প্রশ্নের উত্তরটা কি? When we say that we have a particular solution in our differential equation, what does it mean? Okay, I don't have that much time to again recap the thing. Let us proceed with. Now you have these two equations there where your trapezoidal rule will give you the most accurate result. But your method of undetermined coefficient means your integral can be approximated as a weighted sum of the function values at the two intervals a and b. That weights are C0 and C1. These are the coefficients that you need to determine. So for your trapezoidal rule simple, what you can do that, you can simply determine this thing by using these two examples. One is between your minus b by minus b, a divided by 2 to b, a divided by 2, you have a simple straight line horizontal. Then you can put the values of fa and fb there. Those two values are equal to 1. You will obtain the first equation. Then in the case of a straight line, your range of integration is same. It is y equal to x. So your left hand side is equal to minus b minus a divided by 2 to b by 2 x dx. Now your fa equal to what? Because in your equation 22.17, you have to put the value of fa, isn't it?
Yes, sir.
What is the fa for the letter case? Your letter case is what? You have a straight line, something like this, okay? This is the thing. This is your minus b minus a divided by 2. This is your b minus a divided by 2. Your function value at this point equal to what? Is it not this?
Yes, sir.
And your function value at this point equal to this. So you can easily integrate this. What will be the value? You can solve these two equations to find your C1 by C1 and C2. Then that C1 and C2 can be used there to find an alternative of our trapezoidal rule that will give you a bit more accurate result. Okay, this situation can be generalized if we can have our situation that is not a straight line, something like this. In this case, what you can do, your general concept is very simple, that we can use a polynomial there. That polynomial we'll have the basis functions. Okay. The first one is 1, second one is x, third one can be x squared, fourth one can be x cubed, and so on and so forth. If we are using the order, then your complexity of your problem will be gradually increasing. That particular thing has been explored in the derivation of Gauss-Legendre formula, and sometimes it is called Gauss quadrature formula. Okay. So the discussion is there. So with this thing here, you see that we are going between point, but one important issue is that here the integration limit is set to -1 to 1. And you see that if you have our 4 cases there, one is y equal to 1, that will give you equation 22.19. If we have our equation y equal to x, it will give you 22.20. If we set y equal to x square, next equation, y equal to x cube, next equation. The right hand side can easily be evaluated between the limit -1 by 1. Then f0 can be determined from the curve, that in the case of a straight line, your f0 would be equal to 1 and x1 would also be equal to 1. In the other cases, this value are the, but in general, these values of x0 and c0 will not be known to us. If they are not known to us, then what you can do, you can put the value of your function point there. That function point, you understand the thing? Okay, here you see that in this equation, what will happen? Our case, y equal to 1. If it is y equal to 1, your function value, say this is a straight line, okay? If we consider this is your x0, this is your x1, in both the points, your function values are equal to what?
1.
1. If we have our something like this, then what will happen? This is your x0, this is your x1. Your function value would be equal to minus x0 and plus x1, something like this. Okay, in this way, you can replace your function value by using the nature of this curve in centered at the origin. Having this thing there, we will find 4 equations with 4 unknowns. Those unknowns will be equal to x1, x0, c1 through c2. Then 4 equations are there with us. You can readily solve these 4 equations. That will give you that for the case of 2 point, because here we are using 2 point x0 and x1. For 2 point Gauss-Legendre formula, c0, c1 would be equal to 1, x0 would be equal to 1 by root 3, and x3 would be equal to x2. 1 would be 1 by root 3. If we place this equation to our general equation, that was equal to c1 fx1 and c3 c2 fx. Original equation was what? Your I is equal to c0 fx0 plus c1 fx1, isn't it?
Yes, sir.
So we obtained that our fx0 would be equal to -1 by root 3, and your x1 is equal to 1 divided by root 3, and we obtain c1 equal to 1, c0 equal to 1. Then this, is it not that equation?
Yes, sir.
What interesting thing can be observed from this equation?
Sir, it is complement.
You see that it is very simple. You are simply calculating the function values at these 2 points, isn't it?
Yes, sir.
That will give you the thing. But the real problem is what? This equation is derived with the assumption that your integration limit should be from -1 to 1, isn't it?
Yes, sir.
But not always that your integration will be between these 2 limits. Then what you can do? In this case, if you, for example, if we have a limit between a to b, and we need to transfer it from -1 to 1, how can you do that? Don't you know this thing from the intermediate level algebra, that you can substitute a variable so that
Yes,
this
sir.
thing will be -1 to 1?
Yes, sir.
Yes, sir. Sir, একটা
So
intermediate
that-
variable assign করে নিতে হবে।
Yes, that is what the thing. Okay, we are introducing an intermediate variable xd. That is what equation 22.24, and you go all the way, you will see that we will find a relationship that will give you the relationship between x and xd. Xd is your new variable, x is your old variable. As a result, your integration limit will be from 1 to what? -1.
Sir, is
Yeah.
this topic somehow related to the Legendre polynomial from linear algebra?
Somewhat, yes, because name is there related to Legendre, but look, very lowest order Legendre polynomial. Okay.
Okay, sir.
So the general translation equation will be 22.29 and 22.30. So if we have these two equations with us, then you see that you can, or in original equation, you can replace with independent variable x by using equation 22.29, and your dx can be replaced by this quantity, okay? Then what you will have a new function there that will be the function of xd, isn't it?
Yes, sir.
Because some official issues are there, people are continuously hunting. You see that we have our original integration between a to b fx dx, isn't it? Now we have an integration from -1 to 1. Our fx is translated into xd, and your dx is equal to dxd. We will have a factor there, isn't it?
Yes, sir.
So this is what the logic, okay? Now, once this fd is available to you, do we need to integrate? We do not need to integrate. We simply need to calculate the value of x xd equal to -1/√3 and x xd equal to 1/√3, okay?
Yes, sir.
Then these two values will give you the integration result. This is actually illustrated in your subsequent pages, okay? As I try to go through it, I have to quit at this point because some issues regarding admission test probably they need my intervention. So I will give you percentage from your attendance book from what we call Google, or even you can consider it in the next day, no problem. Thank you very much.
Sir,
I will, okay, your content of your mid exam will be up to your interpolation, okay?
okay, sir.
So any special suggestions, sir, to prepare for the exam?
Okay, that yeah, so sorry, what?
So any suggestions how we should?
Suggestions is actually cannot be possible. The reason is that as it is online exam, in this case, you can expect your problem that will be related to your electrical engineering, and you will eventually derive the equations to, for example, say in your last test,
Yes, sir.
let me just take another 5 minutes, okay, to discuss, okay?
Yes, sir. Sure. Yes.
Actually, unless you can relate your thing with your field of study, you cannot you will never be able to know the importance of your learning, okay? Because your network has a problem. Now I am with you
Yes, sir.
Yes, sir.
because I connected now with my mobile data, and my mobile has not sufficient data because my Wi-Fi network is 100% down. I don't know what happened. So you see that, for example, whatever thing we learned some simple solution of differential equation, isn't it?
Yes, sir.
By using
Yes.
Euler algorithm in chapter 1. Can you cite, can you find some example of this thing in electrical engineering that I just illustrated just few minutes
Yes,
ago?
sir. RC and RL circuits.
Okay, fine. Okay, even without RCL and RL circuit, you may have, for example, a network something like this that may contain, for example, more circuit in it, say E, and say L1, this is L2, say this is R, and you have been asked to calculate the current I1, or even we can ask you to calculate I1. Can't you apply your Kirchhoff's current law or voltage law there to derive the equations?
Yes, sir.
Yes, sir.
How many equations will be there?
Two equations.
Two.
Among both equations will be, in the transient case, will be what we call a differential equation, isn't it?
Yes,
Your
sir.
first loop will be equal to what? Minus E plus L1 di1 divided by dt plus R into I1 minus I2 equal to 0. That is what your first equation. Your second equation would be equal to what? Your
Sir,
second equation
L2
equal to I2 minus I1 multiplied by R plus L into di2 divided by dt equal to 0, isn't it?
Yes, sir.
Okay, can you combine these things together to find a single differential equation? And this is
Yes, sir.
is it engineering or mathematics?
Mathematics.
Okay, that be careful. So, but in my case, for that thing where differential equation is involved, I will not give you something like this. It will be confined with, if you want to derive, if you are needed to derive, your derivation will be first order type. Second, we learned about Gauss's formula. What we call curve fitting, say. I told you that if we have a BH curve, and that data is given to you, your H data and B data is given to you. And we know that your BH curve will follow a equation. That equation can be written as A equal to, say, AH divided by some constant B into B equal to H. Okay. Can't we fit this equation with this data? Didn't
Yes,
we explain it in my earlier lessons?
Sir, it
Yes,
should
sir.
be like a B equals to A0 plus
This
A1.
is
into
your
A2.
purpose. The way you have to move, I have already discussed. Okay. In your book, you have examples. Try to find, so resolve it. I hope you will find it. Okay. For example, in the case of Gauss-Seidel method or LU decomposition, what you need? You need a matrix, isn't it?
Yes, sir.
If you need a matrix, how to find a matrix? If I give you a circuit with many loops, and that is tractable, a loop will be limited to 3 by 3, not more than this. Then can't you find your first year algebra there to derive the equations using Kirchhoff's current law?
Yes, sir.
Yes, sir.
Then you can easily solve it.
Yes.
The latter thing will be simple. In one of my last class tests, I have given a problem very simple, that your inductance current is changing in this way, A1 into T. A table of 3 points were given, or 2. I said that try to put this thing into, because sometimes you see that if you want to use Gauss-Seidel method, what is the characteristic matrix you need to find?
Sir, আমাদের যে
তোমাদেরকে কি বলা হয়েছে সেটা বড় কথা নয়, কি শেখানো হয়েছে সেটা বলো। এই ইকুয়েশনটা হওয়ার কথা এরকম নাকি?
Yes, sir.
With A1 by A2, can you use the equation at this form by in your Gauss-Seidel technique?
No, sir. In Gauss,
And
no,
which
sir.
form? I have given their hint also. Put this equation into
Sir,
diagonally dominant form.
Yes, sir. Pivot করতে হবে, sir.
Diagonally dominant form মানে কি? You have to change the variable there. It will come there. Okay. That means you write
Yes,
your equation in this way: 5 into 1, and
1.
corresponding thing should be there, A1 and A0.
It is you.
There you have to apply. Is that thing need further hint? So,
No,
so you
sir.
can expect this type of problem in your final exam. Inshallah, thing will be very simple. Okay. And some of you actually are not considering your exam very seriously. Be careful about that. It is online exam. Utmost care will be taken on the integrity of the policy. Okay. So that's it from my part. Thank you very much. See you after.